Hi, this is Asing. You are now watching Asing Math TV. In this video, we will learn how to sketch the graph of a function using derivatives. So as usual, we differentiate y with respect to x and we should obtain 4x cubed plus 15x squared plus 4x minus 8. And we should differentiate for the second time in order for us to determine the nature of the turning points and also the inflection points. So we should have 12x squared plus 30x plus 4. Next, we know that at the turning point, dy dx is equal to 0, which means that 4x cubed plus 15x squared plus 4x minus 8 is equal to 0. We can make use of factorization, long division, or synthetic division to obtain the roots, or simply make use of the calculator. So we can look for the equation function and we look for polynomial degree 3. And we just have to input accordingly. So we have 4, 15, 4, negative 8. And we obtain x is approximately equal to negative 3.25. We are going to take only 2 decimal places since this is just for sketching purpose, which means that high accuracy is not necessary. So next one, we have 0.57 and the last one is negative 1.07. Then add point of inflection. We have d squared y dx squared is equal to 0, which means that 12x squared plus 30x plus 4 is equal to 0. Again, I'm going to make use of the calculator. So, polynomial this time is degree 2. So we have 12, 30, and 4. So we can take decimal points so that it's easier for us to sketch. So negative 0.14 and negative 2.36. We can also determine the x-intercept, which means that y is equal to 0. We can input this to this calculator as well, since allow us to have up to degree 4. Or for sitting calculator, if let's say we are not able to have degree 4, we can first factorize, which means that we can take out x. So we left x cubed plus 5x squared plus 2x minus 8 is equal to 0. Then most calculators are able to have degree 3. So we have degree 3, then 1, 5, 2, and negative 8. So which means that we have 1, negative 2, and negative 4 for this function. And for this, we have to set to 0. So which means that the point of x-intercept for the x-coordinate, we have 0, 1, negative 2, and also negative 4. With all the x coordinates, we are now able to determine the y coordinate. So we can make use of the table so that it looks better. So x, y, then d squared y dx squared for us to determine the nature of the turning points. So we can start from turning point. So we have negative 3.25, 0.57, and negative 1.07. Then for inflection point, we have negative 0.14, negative 2.36, and for x-intercept, we have 0, 1, negative 2, and negative 4. Now we can determine the y value using the function. So what we have to do here is, if let's say we want to make use of the calculator function, the calculate, then we are able to determine the y value very fast. So we just have to first clear what we have, and we proceed to enter using the alphabet. So x to the power of 4 plus 5, x to the power of 3 plus 2 alphabet x square minus 8x. And we need to calculate what is the value? Negative 3.25. So we obtain. Also, we take 2 decimal points is enough since we just want to sketch. High accuracy is not necessarily. So we have negative 12.95. And the next one, again, calculate 0.57. So we have negative 2.88. And we calculate again for negative 1.07. We have 6.04. And next, calculate again. We need negative 0.14, which is 1.15. Next, calculate negative 2.36. We have negative 4.68. For this, we can double check or we can simply ignore because we know that at x-intercept, y is definitely equal to 0. So let's say we worry that we determined wrongly, we can also check. So calculate when x is equal to 0, we will obtain 0. When x is equal to 1, again is 0. So at point x-intercept, y is always equal to 0. Now we are going to determine the nature of all these turning points. So make use of the d square y dx square. So the one that we obtained here. So we just input accordingly. So we have 12 alphabet x square plus 30 alphabet x and plus 4. Now we have to call for negative 3.25. And we obtain positive value. We can simply put the sign positive, or we want to put the number also doesn't matter. 33.25, and this is greater than 0. So for the remark, we can write since it's more than 0, which means that this is local minimum. Okay, then next, calculate for 0.57 and we should obtain 24 point something. So this is again positive. So again is local minimum. And the last one, calculate negative 1.07 and we have negative value. So which means that this is local maximum. And now we can proceed to sketch the graph with all the information that we obtain. We might have a small difference in the y values due to the decimal numbers that we've taken for x. But this method is not important since this is just for sketching purpose. We can first locate the turning points. For local maximum is supposed to have crying face, local minimum smiley face. We can roughly see the shape. So we have -1, 2, 3, and 4. So positive 1, 2, 3, and 4. And for y-axis, we can check we have 6 and 12. So we are going to use 2, 4, 6, 8, and so on. -2, 4, 6, 8, 10, and 12. We're supposed to have up to -14. Then this is almost -13. Okay, we can roughly sketch now. So -1.07, we are going to take -1 since this is just for sketching purpose, which means that high accuracy is not necessarily. -1 at 0.6, so it's here. We can make the shape crying face. Okay, then local minimum we have -3 and -12.95. So we take -13, so roughly here, and we make smiley face at this point. Okay, then next 0.57. So we take 0.6 roughly here, and -2.88. We are going to take roughly -3, so which means that roughly here, and this is smiley face as well. Okay, so for the point of inflection, as we can see, is in between the turning points. So which means that we will definitely pass through this point. It's not necessarily for us to labor. And we can straight move on to the x-intercepts. So we have here, here, origin, and also 1. We can now sketch. So at the maximum point, we are going to go down and touch the x-intercept. And we go down again and reach the minimum point, and we go up and back to the x-intercept. Then we pass through the intercept. Then for this maximum point, we are going to go down and pass through the origin, and we get into the minimum point, and we move up again, pass through the x-intercept, and go up again. So this is the curve that we are looking for, and hence we done. If the question requested, then we have to label all the points that we have. If the question did not request, or the lecturer did not request, we can just sketch the shape and we done. Okay, that's all for this video. Thanks for watching. Hope you like this. See you.